Hello everyone, my name is Satyam Sonawane. I am from MITAOE first year engineering BTech, and today I will be explaining about binary search and program in Python language. So my topic name is binary search and one program for it. Starting with the table of content, we have introduction, binary search and programming. So we will see all these topics. So starting with the introduction, what is searching? So searching is finding something specific element in a data collection. For example, you are searching for a word in a notebook, or if you are searching something in phone, mobiles through the help of search option or anything. Everything we find in something, some data is known as searching. So for our topic, there are just only two types of searchings, which are linear search and binary search. So what is actually linear search? Linear search means it checks every element in the data. Means if you take an array, so it checks every element and then the search is identified. But in binary search, the data is divided into two halves and then the search for the target is done. So in today's lecture, we will see more about binary search. So let's see what is binary search and let's identify its program and examples. So what is binary search? Binary search is an algorithm used to find an element in a sorted array. So for binary search, keep it in mind that the data should be sorted. And if we take an example of an array, so the data should be in sequence. And if we start counting, so the count starts from the middle. So let's see how actually this binary search works. So here in the PPT, I have given some points to identify how binary search works. If you, for example, if there are 11 data puts in the array, from the fifth data input, the binary search begins. Means the data is divided into two halves and then it is shifted right or left according to the target. So we will identify that how actually the target affects the binary search. If the target is smaller than the element in the middle, then it moves right side. If the target is larger than the element in the array, then it moves left side. So we'll practically understand through an example. For example, if there is an array of 2, 5, 8, 12, 16, 23, 38, 56, and 72, and if our target is 23, so here in this array 16 is the middle element, and if we start uh, searching from the 16th element, 3 is greater than 16, so it will move right side, and if we move right side we'll found 23, and the process of binary search stops there. And if it would have been 12, 8 or any other target, the binary search would have shifted left side. So here I've given the binary search algorithm. So as I said that the binary search starts from the middle, so low and high is divided by 2 after their addition, so it starts with the middle element, and this binary search is repeated till the target is found. Now let's see one program for it. So here I have been taken a function. I have defined a function binary search, and I have taken two parameters, array and one element x. So x is our target and array is a data source. So I have been declared low highs and applied two conditions here, while and bit in while I have applied a uh, conditional statement if, elif and else. So while low is less than or equals to high, the mid value is low plus high divided by 2, means it is a mid value or a middle value of that array. So I applied two conditions. If array's mid value is equals to x, then it will return mid, means the same term, and if it will be less than, then it will move left side, and if it will be greater than, then it will move right side. So it is just kind of example of a program. So let's see output of the program. Here we have taken an input array, and our search element is 23, and 23 is present at the index number 5. So algorithm quickly narrows the area. So what is the mid value? The mid value is 16, and it will move at right side. So 23 is our search element. So let's study some advantages and limitations of the binary search. So advantages are very simple, that it is very fast for the large data sets. Efficient searching uses divide and conquer method. So this is a very useful for large data sets, and there are also some limitations, that it works only on sorted data sets, so no unsorted no unarranged data set will be applicable here. And it's a slightly and it is a slightly complex implementation, so users new users can have some problem, but it is far better than a linear search. So now let's come on the conclusion point. So we can see that binary search increases the efficiency and saves times, and is a very useful algorithm for searching anything in the data. So it reduces the time usage and is very helpful for the coders. So I hope that you have understood the binary search very completely and clearly. The PPT has been shared in the description box. You can see the PPT and learn more about the binary search.